Good afternoon and welcome to our South Cumbria and North Lancashire IOSH branch meeting. I'm delighted you could be here with us this afternoon and I hope the sun is shining with you in the way that it is with us today here in Cumbria. We've just got one or two more people joining us and we will let them finish joining before we get started. That's it. I do need to just let you know that the meeting today is being recorded. So if you would prefer your background not to be seen, then do feel free to switch off videos as you see is necessary. And normal meeting etiquette for us is if you have questions for our speaker today, then do please put them in the chat bar. And if you can start them with a Q, it will help us to identify what is questions and what's the chat going on between the different delegates where we're not able to kind of meet and have that conversation outside. So with the housekeeping sorted, I'd like to take this opportunity to welcome Christian Reeve, who is the Head of Safety, Health and Environmental Operations at BAE Systems at Barrow-in-Furness. And Christian's working on a number of initiatives that approach safety management from both a proactive and reactive perspective. So he's going to consider some of the advantages of each approach and how it can develop through the maturity of an organisation. Christian joined BAE Subs in 2019 and has previously worked in other high hazard industries, including oil and gas, nuclear power and chemical manufacturing. So he brings a wealth of experience and challenge into a growing and dynamic organisation. So can I hand over to Christian for his presentation today, please?
Okay, afternoon everybody. Can I just check that you can actually see my screen, which I'm sharing?
Yes, we can.
You can, fantastic. Thank you for everyone for taking the time to come and join the call today. I hope you're all enjoying the lovely sunshine today. Let's make the most of it while we can. And thank you for the introduction, Elsa. Really appreciate that. So as Elsa said, my name's Christian Reeve. I'm the head of SHE from BAE Systems Submarines, based primarily out of Barrow-in-Furness. So today I'm going to be covering the topic of Safety 1 and Safety 2. So those in the profession may have heard of these terms before. I've only very recently started to look into the theory which sits behind Safety 1 and Safety 2, and it's really been inspired by some of the people I follow, some of the safety academics which I follow, such as Sidney Dekker and Eric Hognagel. So today's presentation is really going to take us through some of the basics, some of the theory around Safety 1 and Safety 2. We're then going to talk about some of the potential methods and processes we may be able to put in place to try and move towards a Safety 2 position. Okay, so the way the presentation is going to run, I'm going to do some brief introductions. I'm going to talk a little bit about BAE Systems Submarines, just to give people a snapshot of my organisation. I'm going to cover a summary of Safety 1, what that means, what the Safety 1 mindset is. We're then going to move through really to get into the nooks and crannies of where it came from. So we're going to talk about the evolution of safety thinking. We'll then cover Safety 2, the basic principles and foundations of Safety 2. I'm going to really major on this topic, which I think is really important, and this is work as imagined versus work as done, which is a really important part of Safety 1 and Safety 2. We'll then talk about how we potentially may move towards a Safety 2 position, and then a little bit of a wrap up and a conclusion. Before I start, I've had quite a few conversations around Safety 1 and Safety 2 with various colleagues and professionals, and one thing which is consistent is there is certainly a mixed bag in terms of opinions. I've spoken to some very traditional safety practitioners who've got certain opinions, and I've spoke to, I'd say, more upcoming and inspired safety practitioners who really see something in the safety 2 mindset. So I don't think there is a right or wrong answer from today. I'm not coming here to say we should all move towards a safety 2 mindset. I'm going to give you some theory, and I'll give you my personal opinions as well. Okay, so first of all, just a little bit about the business that I work for now. So as Elsa said, I've been with BAE Systems Submarines since 2019. Prior to that, I worked in nuclear power, offshore oil and gas, chemical manufacturing, and I've also actually started out my career in the military many years ago. My current role at BAE Systems, I'm the head of SHE, and I've recently moved into a position where I'm really focusing on what we call the Astute programme. So BAE Systems Submarines is part of the wider BAE Systems enterprise, and we're part of what we call the maritime and land businesses. So within maritime and land, you have the submarines business. We also have a business which builds surface ships. We've got a business which maintains and overhauls the current Navy's fleet of surface ships. And we've also got some businesses which focus on land weapons. In the BAE Submarines business, we've currently got 10,000 core employees. These are located across 7 locations in the UK. The main population is certainly at Barrow-in-Furness, which is our main construction facilities. And that 10,000 is spread across what we've called production workers, our office workers, and also our new home working population due to the COVID pandemic. We're currently working on 2 main programmes. The first one I'd say is most of the way through and is moving quickly towards an end, and that's the Astute programme. So the Astute class submarine is the Royal Navy's hunter-killer submarine. It's an attack submarine used for reconnaissance and action against enemy vessels. The up-and-coming Dreadnought programme, so this has just started. It's a significant programme of strategic importance to the UK. So Dreadnought is our nuclear at-sea deterrent. So this is the submarine which carries the nuclear missiles and would react to any threat against the UK if required. In terms of the types of submarine they are, the Astute class is a much smaller submarine. The Dreadnought class is nearly twice the size, just shy of twice the size actually. And I suppose in terms of the business, we are quite a strange business. We've got 2 programs, but we've actually only got 1 customer. Our only customer is the MOD and the Royal Navy. We're the only people that supply submarines to the Royal Navy. So we really, if you take a holistic approach, don't really have any competition, certainly in the UK. Okay, so in terms of the work environment at the submarine construction facilities, there's although you know the end product is submarine. To get there, we go down lots of different winding roads, and we have some quite complex problems we need to overcome. First of all, when we talk about the Dreadnought boat or the Dreadnought submarine, it is a first-of-class submarine. So nobody's ever built this submarine before. It's a brand new design. And when we have now started building it, but it's the first time it's been built, which brings in all sorts of issues and complexities. The general environment in our construction facilities is a high hazard environment. So we have everything from high hazard lifting operations to confined space to high energy hot work. And at some parts in the build evolution, we've also got a live nuclear reactor to deal with. So you can see from the type of activities we're conducting and the type of product we're making, it is really complex, high hazard environment. And the environment is very fluid as well. So it's not your standard production line where one thing goes at the end and comes out in a linear fashion. The product moves, and it can move on a daily and a weekly basis. It moves between facilities because the construction areas are broken up across a number of facilities over quite a large site, but also within the main construction halls as well. The product does move. You can go in one day and 2 days later, when you go in, the area looks significantly different. So again, that brings in additional complexities which we need to deal with. Okay. So safety 1 and safety 2. I'm going to start really because before we get into the detail about the theory, I really want to just give everyone a little bit of a summary around what Safety One is before we start to talk about the detail and the evolution of safety thinking. So some of you may have done research into Safety One and Safety Two, or been party to some of the information on the World Wide Web around Safety One and Safety Two. So I'll try and keep this summary very brief, but essentially Safety One. So most people think of safety as the absence of accidents and incidents. In this perspective, the term Safety One, safety is defined as a state where a few things as possible go wrong. A Safety One approach presumes that things go wrong because of identifiable failures or malfunctions of specific components, and they can be technology, procedures, or humans, or organizations. Humans acting alone or collectively are therefore viewed predominantly as a liability or a hazard, principally because they are the most variable parts of the overall system, the most variable component. The purpose in Safety One is really to, the purpose accident investigation, in Safety One, is to identify causes and contributor factors and adverse outcomes, while risk assessment really aims to determine their likelihood. The safety management principle is to respond when something happens, so it's reactive, or also respond when something is categorized as an unacceptable risk, usually by trying to eliminate causes or improve barriers, or sometimes both. Okay, so Safety One thinking is, I'd say, where, certainly from my experience across a number of organizations, is where we are now in terms of safety thinking. So most organizations I've worked in are very reactive. We tend to focus on what goes wrong and react to that situation. We then try and trace things back to a cause and identify contributing factors, and then either eliminate the cause or improve barriers. And that's how we manage safety. So it's focusing on what goes wrong. Really understand where that comes from, you need to understand the evolution of safety thinking. So the world has continuously changed since the Industrial Revolution. During the age of technology, from around 1760 to the late 1970s, numerous technologies were invented, such as the steam engine or the railways. It was, of course, important to ensure that these technologies work reliably and without causing any harm to humans or the environment. In case of a malfunction of any of the components, the faulty machine was taken apart, it was broken down into its constituent parts, and the faulty piece was identified. Large accidents in the 70s and 80s, such as 3 Mile Island and Chernobyl, pointed out that this process was flawed because we'd missed the human element, the human factor. In the age of the human factor, it just made sense to apply the same methods and methodologies to deal with the human element as we did with the technical element. So, for example, breaking things down into their constituent parts, tracing back, identifying who failed, and then fixing that failure. Like technologies, humans were seen as either successful or unsuccessful. We call this the biomodality principle. Somebody must have failed when something went wrong. The larger the accident and the higher the number of injuries and fatalities, and the more severe the mistake must have been. Large and serious outcomes have equally large and serious causes. The more serious an event, the more can be learned. To prevent accidents from occurring and reoccurring, the faulty human operators, equal to the broken technical components, have to be identified, retrained, or replaced. Okay, so from the period of the late 70s onwards, this was categorized that performance had to increasingly get faster, better, and cheaper. Yet incidents such as explosions of the Challenger space shuttle in the late 80s, this really pointed out the potential consequences of such aggressive strategy and the need to account for also organizational factors. So during the age of safety management, the development use of safety management systems had become the central and typical nucleus of the HSE efforts in many organizations and industries. Such efforts focused and could be explained from technologies from human, organizational, but also system factors. And yet the underlying assumptions about the functioning of these technologies, those human, organizational systems, still remained unchanged. So there's the same thought process was still in place about how you would destruct and identify failures within those systems. Safety one assumptions, they may apply to very simple work processing and systems that are well understood, well tested, and relatively uncomplicated. Yet compared to the beginning of the 20th century, today's work environment has dramatically changed. Traffic volume has increased in the road and in the air. Computerization, automation are unstoppable. Engines have become stronger. Transport takes place at higher speeds and greater distances. And production is still expected to become even faster, better, and cheaper. So in summary, we can understand where that mindset came from. It was a very simple mindset. It was about machines. It was about how we would identify failure by breaking things down into parts, identifying those broken parts, and putting things in place to make sure it didn't happen again. As time moved on and things got more complex, we still now try and apply the same methodology to a more complex environment, and it doesn't always work. Okay, so this man, Frederick Winslow Taylor, and if there are any sort of engineers in the room, you're probably familiar with this person. So this individual was the first person who came up with the concept of scientific management theory. So scientific management theory has really influenced and shaped organisations and humans today, and also the way we treat incidents, accidents in safety too. In 1930, Taylor introduced the scientific management theory, and in particular, he introduced something called time and motion studies. Taylor believed that you could improve efficiencies by understanding work as done, and then developing what we call work as imagined. So understanding the most efficient way to do a certain task, describing that in a process or a procedure, and then getting humans to adapt their behaviours to ensure they do not deviate from that procedure. And this is really where the production line came from. Taylor did achieve significant efficiency improvements for relatively simple tasks by designing and writing procedures, and then ensuring that humans amended their behaviour to align with those procedures. And in that age, at that time, he was relatively successful because they were dealing with simple environments, simple products, and simple processes. We all now know that the world has changed, and it is continuing to change. So the world is becoming increasingly complex, and so is operations in various socio-technical systems such as aviation and medical care. Multiple diverse parts such as people, operators, technologies, organisations are all interdependently connected to adapt to the surrounding conditions. The result is a complex interplay of different actors and compounds that potentially give rise to outcomes that are difficult and in some cases impossible to foresee. As a consequence of increased complexity, socio-technological systems are becoming more difficult to track. By the time the system has been thoroughly described and modelled, it may have already changed and adapted. So some of the pictures on the slide there really demonstrate the evolution in technology. So the top three pictures there, you can see this is actually the air traffic management training. So from the 1970s up until the 2000s, in terms of how we trained air traffic control operators. And you can see the stark difference in terms of the introduction of new technologies, etc. And the bottom three pictures there demonstrates surgery. So from the 1970s to the 2000s, moving from quite basic setup to single surgeons now using equipment to carry out keyhole surgery. So the environments are very, very different to what they were. On the left-hand side of the slide, you'll see that diagram. So this is a self-reinforcing cycle of technological innovation, and I think this really describes how the world is progressing and why we get such advances in technology at such a pace. So the reasons for most forms of technology is to compensate for human capabilities. Okay, so we want to do a task. Historically, we may have employed or engaged with a human to conduct that task. Humans are bounded in terms of their capabilities. So we try and compensate by using automation or smart technology. That note will normally bring us some performance improvements. We then get improved technology as time goes on, which leads to greater system functionality, and that leads to greater task complexity. The only two stable parts of that model are the human capabilities, which don't improve at the same rate, and increased performance demands, which we've seen year on year on year. Okay, so technology is improving. The way the human really understands what's happening is diminishing because it's getting so complex. Okay, so a couple of foundations of Safety 1 then. So the first one is that systems are decomposable. This really means that any system, whether that be a technological system, whether that be an organization or a techno-social system, they can be decomposed and broken down accurately into their constituent parts, which means we can then identify a part which was at failure and then rectify that situation. This actually does work for, I'd say, technical equipment, and in some cases we can break things down. You know, you think of a CT scanner or you think of a car, you can quite easily break that down into its constituent parts and find a faulty piece. But when you try and apply that same model to human situations, to organizational situations, it rarely works. Over the years, we've tried to make it work, and you'll all be familiar with various human performance taxonomies and typologies, and we hear things about, you know, inadequate supervision or loss of situation awareness. These are all attempts to try and compartmentalize the human and the social technical elements, which is very difficult to do. There is a belief also in the Safety 1 mindset that function is what we call bimodal. So in a machine, a component is designed and it is either functioning or is it not functioning. And that's quite easy to do because it's designed that way. Again, when you try and apply that to humans or social technical environments, it doesn't really work. So you'll hear again, you know, a lot of modern day practices talks about non-compliance and compliance, and this is essentially the same as function or malfunction. There's a belief in the foundations of Safety 1 also that if the part of the constituent part is functioning as it should be functioning, you will always have a successful outcome. And when you have an unacceptable outcome or a failure, something is always malfunctioning or not in compliance. Okay, so a very basic theory applied to quite complex systems. Okay, so hopefully that gives you a little bit of an overview of what Safety 1's about. So, you know, the way I'd summarize Safety 1 is the way most organizations think today. We focus on failure. When we have those failure events, we investigate, we break down into constituent parts, we try and put things into nice buckets or taxonomies or typologies to make ourselves feel great that we've identified the cause. We then try and put things in place, either by eliminating the cause or putting barriers in place so it doesn't happen again. Okay. Safety 2 is slightly different. So Safety 2 offers an alternative complementary view of safety, actually. It questions some really widely held assumptions. As outlined previously, Safety 1 regards a safe system when negative results are absent, so we're not having events essentially. Safety 2 challenges this assumption. Referring to safety as the absence of negatives implies to focus on the lack of safety or unsafety. Safety 2 defines safety as a presence of positives, such as people's capabilities, capacities, and competencies to make things go right. Hence, safety is present when as many things as possible go right. In Safety 1, a perfect level of safety is when there is nothing to measure. You know, when you're getting 0 accidents, 0 incidents. So a perfect level of safety in that system is actually unmeasurable. When you get to that point, there is nothing left to measure. Low counts of things that go wrong make expense on safety difficult to justify. Reductions in safety efforts slightly follow. So it's very difficult to justify spending money on safety when you're having 0 accidents. So really focusing on diminishing numbers is just it's really highly questionable measure of safety. The absence of negatives is really a poor predictor for safe operation for the future. And there's a really good example of this. For instance, the Deepwater Horizon, and for those that are familiar with that catastrophic event, days before the event happened, on the 20th of April 2010, the management had been awarded a prize for achieving 7 years without lost time injury. And that was days before that catastrophic event happened. So they were measuring not a lot. They weren't having a lot of accidents. They weren't having a lot of incidents. However, something was drastically wrong with the system, which led to the catastrophic event. So stage 2 really challenges the prevailing attitude towards humans and organisations. Systems and organisations are no longer deemed basically safe and undermined by unreliable workers. Instead, humans are seen as valuable and necessary resources for the flexibility and resilience of an organisation to succeed. Workers are a solution to harness because they know how messy the details of work are and how to get work done. Rules and procedures are no longer regarded as entirely complete and applicable to any work situation. For work to succeed, people have to constantly adapt and adjust their performance to local circumstances. So this is all around performance variability. In a safety one mindset, people have a procedure, and the work has been designed a certain way, and people must be compliant. They must carry out the procedure in the way described. Therefore, you'll have a safe outcome. That's really flawed thinking, in my personal opinion. Humans vary their behaviour and their actions in light of the conditions which are presented to them. So humans are not robots, so it's very difficult for them to either be in a male function or a function state. They have to take in the information and the surroundings of the environment and adapt their behaviours to ensure that things are successful. So a couple of foundations around safety 2 then. So performance variability rather than biomodality. So it's understood in safety 2 that the reason things go well, but also the reason things go wrong, is down to performance variability. Humans will have to take decisions at certain points in the task or the activity to ensure the task either succeeds or fails. You can't rely on a procedure to do that. And if people follow procedures 100%, then normally the task would not be done. You can see by the diagram on the right hand side there, so the greyed out boxes there, that was the diagram from safety 1. So you're either functioning or you're malfunctioning, and that can lead to either, if you're functioning, to a successful outcome, or malfunctioning to a failure outcome. In safety 2, it's understood that, you know, everyday work exists performance variability, and actually that performance variability can lead in some cases to success and some cases to failure. The bottom part, so the causality credo, is a second foundation for the safety 2 principles. So since performance adjustments and performance variability constitute the foundation of safety 2, it follows that the mechanisms cannot rely on causality and linear propagations of cause and effect. Although it's still common to attribute some major simplistic incidents to that method, it doesn't work and is not an effective solution for all. So you're all the practitioners in the room, you'll be used to the well-known models, whether that's the domino theory, Swiss cheese, root cause analysis, tripod beta analysis, etc. These all use basically linear models to try and identify causes. But when you're working in a complex environment with multiple pieces of information, multiple environmental factors, sometimes it's very difficult, if not impossible, to actually get to a true cause. The environment is just too complex. Okay, so a comparison here between safety 1 and safety 2. So as I said before, safety 1 focus on what goes wrong. Safety 2 really looks at things which go right. So So in safety one, the general solution is known as find and fix. So look for the failure and the malfunction, try to find their cause, and then eliminate the cause and improve the barriers. The situation is quite different for the 999 events which occur, which actually have a positive outcome. So if you look at the diagram there on the right-hand side, that's a 1 in 10 to the power of -4 probability rate for an event. So 1 in 10,000. And this is typical across a number of different variances across industries. So in safety one, we wait for that 1 in 10,000 event. We then scrutinise it, investigate it, identify causes, and then try and put controls and barriers in place. We ignore the other 9,999 times that activity actually succeeded and went well. So safety two tries to look for what goes right. So rather than waiting for the event to happen, we look at why an event was successful. And it really makes sense when you look at the model on the left-hand side here. So this is a distribution of events. Some of those will have will result in a negative consequence or a failure on the left-hand side there. And that may be an accident, a disaster, or a loss of some sort. You also may have things on the other end of the scale, which we call exceptional performance. So, you know, when things go really, really well. But actually, the part in the middle, the normal routine day-to-day performance, is always ignored. Where actually there's lots of opportunity there for learning, really to understand why something went well and try and learn from that and ensure it's repeated time and time again. Okay, so this is about opportunity to learn. You know, you can either go with safety one where you wait for the event and you try and learn from that, or you go for safety two where you are on a daily basis looking for those things which went well and you are focusing on those and trying to understand why and how they went well. Okay, so this is something I think is really important with this concept, and I mentioned it before. Work is imagined versus work is done. So Taylor, back when he put scientific management theory together, the approach he took was he would get a team of managers or engineers, and they would design the way the task should be completed. So they sit in a room, they think, what's the most efficient way to do this task? They would then design that task. They would then ensure that the operators were then aware of the process, the procedure, and they were trained to complete the task. Safety 2 really flips that on its head, and Safety 2 says actually we should try and understand how work is actually done and then adapt how work is imagined around that. So bringing work, building the resources and the processes and the tools and the people around the way work is actually done. So removing blockers, ensuring that we've got a path of least resistance is actually the way we should be carrying out our activity. So this, for me, is the only way we can really look at successes is by using this as the basic principle. So what we're actually trying to do when we go and look for these successes, we're actually trying to identify work is done. And when we go out and look at how work is done, there is no right or wrong way. Humans are behaving in a certain way, or performing in a certain way for a reason. We need to try and understand that. We also need to try and understand where performance variations potentially may lead to catastrophic consequences. So if people are making decisions in the workplace or during an activity to compensate for their natural surroundings or the environment or the equipment they have, we need to understand what actually is the potential consequence of that if they do make the wrong decision, and that's where we should be focusing our attention. So work is done needs to happen on a daily basis. It's not something which we can do from an office. Work is done is about getting boots on and going out with the guys and girls and really understanding what are their issues, how do they get work done, what decisions are they making throughout the day which may not be in line with the work as imagined. Once we've done that and really understand how work is done, we can then start to work on the work as imagined piece, and that's actually aligning our procedures, our processes, aligning our resources to as closely as we can to work as done. Okay, so moving forward. So as I said before the start of the presentation, I did struggle with the concept initially. you know, when I first started looking into this, you know, I've been in safety management for a number of years, and I'd say I've got certain beliefs and concepts which are entrained into my mindset. So I had to really do some deep thinking and really explore the theories around this. And actually, when I reflect back to the majority of organisations I've worked for, you know, I could quite easily say we're certainly in I'd say safety 1 mindset. But moving towards safety 2, so there's a few things which organisations can do, and it's well documented to try and move towards a safety 2 mindset. So the first one is about being sensitive to operations. For those that are familiar with the principles of high reliability organisations, one of the traits of a high reliability organisation is what we call sensitivity to operations. But essentially, in layman's terms, sensitivity to operations is work as imagined versus work as done. That's closing that gap between how people think work is happening and how work is happening, and ensuring that resources are aligned to make it the best environment and the best process and the best work day for the operator at the sharp end. So being sensitive to operations, so closing that gap, whether it's from a leadership perspective, whether it's from safety practitioners going out and doing that, whether it's team leaders or colleagues, taking that time to really understand how work is done. And this needs to be an actual physical activity rather than a paper-based or desk-based exercise. Also looking for what goes right. So within every organisation, the majority of the time things go well. Even in I'd say the organisations with the worst safety performance you can think of, the majority of the time things go well. So what makes them go well? And that's what we need to understand. One of the principles around safety 2 also challenges the concept of let's put all our attention into those events with the highest consequence or the potential for the highest consequence. It asks us to consider frequency rather than severity. Okay, so do we get greater performance improvements and safety performance improvements from making the highest frequency activities more successful, or by waiting for one higher severity activity and making big improvements on that? So for me personally, I think you need both. It needs to be a mix. But we do as organisations tend to forget about the lower frequency, the lower frequency events, and the detriment to the high severity events. So some of the principles of safety 2 is about consider frequency as well as severity. Remain sensitive to the possibility of failure, and it really does require a mindset change for your organisation. So failure. The term failure is derogatory, first of all. So that type of language shouldn't really be used. If somebody is not working as imagined, then that's a performance variation. It's not right, it's not wrong. They've done that for a valid reason. So they've done that to deal with their current situation, their current environment, and we need to understand why. And 90% of the time, that's probably going to be the right decision to make in that scenario. We need to make sure that doesn't present a significant risk further down the line to the business. But we need to be sensitive to the possibility of failure. People out there, whether you like it or not, are not following procedures to the letter or processes to the letter on a continual basis. They are enacting performance variance to get the job done. And the last one is about being thorough as well as efficient. So when you think about some of the activities which Safety 2 recommend, it's about going out, spending time with your operators, understanding their day, understanding how they get activities done, understanding what decisions they make, why they make those decisions, and what impact that may have in the future or on the activity. That takes time. In most organisations, time is seen as money. So it can be very, very, very difficult sell to, in most organisations, to allocate resources to do this, to go and start looking at things which are frequent activities, potentially low severity activities, but it's things which are actually normally going well and there is no adverse outcome. So most organisations say, well, why are we going and looking at this stuff? Why am I spending money on going and looking at these things which are going well? They're going well, let's just leave them alone. But there's so much learning to be had there, that 999 cases out of one. So much learning we are potentially losing. So the last one is about being thorough as well as efficient. You know, it is going to take resource up front to be thorough about doing this, but the efficiency comes down the line. And actually, this is more than safety. You know, if we can get this right, and with the safety 2 mindset, it's not just about improving safety, it's also about improving efficiency. And I think this really links into the future of a safety professional. And me personally, and this is my personal opinion, I see that's where the profession is going. So being seen as more of a continuous improvement and resilience engineer, rather than somebody who polices standards and polices procedures. So for me, this is where we should be going. When we can get to a place where actually safety is seen as efficiency and is linked directly to efficiency, then, you know, the allocation of resources becomes much more easy. Okay, so there are now there's quite a few examples of organisations which are trying to implement sort of the safety 2 mentality, and I've mentioned 2 here. There are more. In the presentation, there is a link to a white paper which was done, which does discuss more methods and routines to actually go and look for what goes right. So for those that are interested, the link is within the presentation. But I picked out 2 examples. The first one is something which was actually developed and is used by NATS. Really simple. They called it the day-to-day safety survey. It was, as I said it before, it was approached by NATS, and it can be used to understand performance, variability, and adjustments in work as done. So this is simply time spent observing everyday work, for instance, in operational areas, with or without a particular method. So it's very relaxed, very informal, and it's really important for safety specialists, and I'd say leaders, to really understand how things really work. So this can be really valuable too. From a personal example of this, something we've very recently initiated at BAE Systems is what we're calling tactical engagement teams. So this really aligns with this day-to-day safety survey approach, and it's less of a leadership tour. You know, let's put the red carpet out, let's get a senior leader to walk around the facilities and speak to people. This is more around a day in the life of. So the tactical engagement teams we've recently introduced are a team approach where a senior leader, somebody from what we call our operations function, so this person will be someone who understands the job, so it could be a welding trade lead or an electrical trade lead, and also a safety advisor, work as a team to actually go into the workplace, and they live a day in the life of the worker. So they turn up 6:30 in the morning when the shift workers start, and they see where they're getting changed, what environmental factors are influencing them before they get into workplace. They're then attending their start of the day briefs, their toolbox talks. They're then going out and actually observing those people in the workplace. And it's not to look at what they are doing wrong, it's to look at how they are working, okay? And then just trying to identify where there is potential performance variance. So it's something very new we've kicked off. It's still evolving. I don't think we're quite there yet in terms of getting the right outputs, but it's a start, and we're going to continue with that. The next example there, and again, this example is also in the link, is team resource management. So this involves strategies for the best use of available resources, information, equipment, and people to optimize safety, but also efficiency. So the origins of team resource management does not come from safety. It's actually an efficiency tool which has been adapted and applied in a safety setting also, because as I said before, to me, the two are intrinsically linked. Okay, and this is again, it's about understanding how things go right in operations. This actually, part of TRM is, part of it is desk-based, so it's looking at how materials, equipment, training, etc., is delivered to the sharp end of the operation. Then it also involves a day in the life of or a physical observation activity as well. So as I said before, they're 2 examples. There are more, lots more, and actually, I'm sure most of the people, most of the safety practitioners on the call will be able to think to their own organisations, and actually you're probably doing some of this stuff already. It may be under a different name or different guise, but certainly I can pick up parts of things I've done previously and parts of things we were doing already as an organisation will actually fit into this safety 2 mindset. Okay, so the question at the start was, safety 1 or safety 2, and I don't know whether I've changed anyone's mind during the presentation. Hopefully, you've got some use out of that and you understand the basic theories now. But in summary, for me, since the socio-technical systems on which our existence depends, as they continue to become more complicated, it seems clear that staying with the safety 1 approach will be inadequate in the long run and probably in short run as well. Taking a safety 2 approach should therefore not be a difficult choice to make, yet the way ahead does not lie in replacement of safety 1 by safety 2, but rather in the combination of the 2 ways of thinking. It's still the case that the majority of adverse events are relatively simple or can be treated as relatively simple without serious consequences. That therefore, they can be dealt with in a familiar way, but there's certainly a growing number of cases where this approach just won't work. For these, it's necessary to adopt a safety 2 view, which essentially means adopting a resilience engineering view. Safety 2 is first and foremost a different way of looking at things, hence also a different way of applying many of the familiar models and techniques. In addition to that, it will also require methods on its own to look at things that go right, to analyse how things work, and to manage performance variability rather than just constraining it. So safety 1 and safety 2, for me, the answer is both. I don't think you can have one or the other and have an efficient and effective organisation or safety culture. I don't think the principles of safety 1 are flawed totally. I do think there's some elements that we can learn from safety 2. But as I said before, this is about thinking slightly differently, maybe getting some of the tools you're already using in a safety 1 environment and actually thinking how that might be applied in a safety 2 environment. The huge takeaway from me from doing this piece of research and looking at more depth into safety 2 is certainly the human element. We should expect that humans will not follow written down or verbalized procedures. Humans have to react to everyday situations, whether that's weather, local environmental conditions, lack of equipment, lack of training, and they always will try and do what they think is the right thing to do at the time. Sometimes that will lead to a positive outcome. On some occasions, that will lead to a negative outcome. But I think on both occasions, we need to look at the learning opportunities from both. It isn't about failure, it's about performance and variation. Okay, so the last slide is really just some references. So for those that want to look into this a little bit more, there's lots of material out there. As I said before, some of my favourite safety academics, Sidney Dekker, talks about this subject quite often. He does call it something different. He calls it safety differently. And there's a very good book by Sidney Dekker called Safety Differently. Sidney Dekker will say himself that safety differently is not the same as safety 2. I really struggle to find the difference. I think there's a lot of comparison there. For people that want to really delve into the originator of the safety 1, safety 2 principle, that's Eric Hognagel. So he's wrote a very good book called Safety 1, Safety 2, The Past and Future of Safety Management. And there's also a number of white papers, which are again linked into the presentation, which have mainly been carried out with the medical and air traffic management and control industries in mind. However, they're applicable to all industries. Okay, well, thank you for listening. Apologies, my camera wasn't on. It's I've had technical difficulties with it today, and you've not missed much, just my ugly mug. But thank you for listening today. Any questions?
Good afternoon. My name's Patrick McMurray. What we're going to be doing is I've been reading the chat, and I'm going to relay a couple of your questions to Christian. We've only got a time for a couple of questions, I think, but so if you don't mind, I'm going to take the questions that have been asked and kind of amalgamate them to some of the key ones. I think one key question that's been brought forward is, how was the idea, the plan behind Safety 2 introduced to the SHE teams and to the board at BAE? What sort of evidence, what sort of support was used, and where did the who initiated the idea within your organisation?
Yeah, so really good question. Actually, unfortunately, the reason we introduced what we call the tactile engagement teams was an intervention to some poor performance, some incidents we've been having earlier in the year. We sat down as a leadership team and tried to discuss what we could do. And there was certainly, views from the majority of the leadership team, but also the wider organisation, was that did we really understand what people were doing out on the park? Okay, so there's certainly that gap, that sensitivity to operations wasn't there across the whole organisation. It was there in parts, it wasn't in others. So we really used this as an intervention, as a catalyst to try and improve performance. So in terms of the actual tactile engagement teams, when you go to a management committee or an executive committee and you ask for their time is very, very precious. So you need to be able to demonstrate the value in doing this. And as I said before, I'd say we're only at stage one of this. We're at the point now where we've got people getting out on the park on a more regular basis and actually change their mindset from we're going out for a red carpet tour to no, we're going out to understand work as done. But we've still got some ways to go. But you have to have a clear argument for this when you go and ask for resource of senior people, because that resource doesn't come to free. But for me, this is all about explaining the theory of what we're trying to achieve here. Not only the benefits in understanding the work is done, therefore moving things out of the way in terms of hazards and issues for the guys, but also that leadership visibility thing, seeing that leaders care and they're going to spend the time, a full day out of their diary to go and spend time in the field with the operators, understanding exactly what they do. And actually, once you start doing it, it sort of snowballs from there. So we've had some amazing, excellent feedback from our senior leaders in the organisation, some of our trader leads, and some of the SHE people as well, to be honest with you, that really didn't understand how certain activities take place, but also what certain things that people were doing to compensate for environmental factors, such as lack of equipment or lack of training or lack of resources. So people were already adapting their work style and their work practices to accommodate for these. So just by identifying that I think was a hallelujah moment for some of the team.
Okay. Another set of questions have been about the sort of workforce. It's easy to see how a highly educated, motivated, well-trained workforce working in a risky environment, such as building a submarine or motorway construction, or in my case, working on a wind farm, would be very easy to engage with these concepts and ideas and putting teams together and what have you. What about the challenge of a less well-educated workforce? One questioner used the example of somebody in the Middle East, or say somebody is working on a beans factory or something, where you're making tins of beans, or in an industrial kitchen, or these sort of environments. How could Safety 2 improve the working environments and the safety of those sort of environments?
Yeah, again, a good question. So at the beginning of the presentation, I talked about the evolution of safety and where this came from. So the Safety 1 approach is most effective for simplistic environments, okay, where you can really, it's quite a simple process. There's not that much interaction with other systems, and things are predictable. Okay, that's when a Safety 1 approach really works, because you can have a set procedure, and if people follow the procedure, it's always going to be okay. You're always going to have a successful outcome. However, I wouldn't underestimate, some tasks you say are simple, or some processes which you say are simple. When you really actually get into the detail of the activity and try and understand what those individuals are doing to ensure a successful outcome, could you confidently say you were aware? On the surface, a lot of tasks appear simple, but actually when you delve into it a little bit more deeper, they're not as simple as you may think, and people may be routinely or habitually implementing performance variation to ensure a successful outcome. And a great example of this, is homemade tools. You go into most factories or manufacturing places, and you commonly find people who've either altered a tool or have made a homemade tool. We try and discourage that as much as we can, absolutely. But that is an example of a performance variation. If we'd have been out there, we'd been looking at what goes right, we'd have understood they were using this tool, why they were using this tool, and actually we'd have gotten the right tool.
I get exactly your point. My very first project was in an industrial bakery quite a few years ago, but it was a much more complex environment than would meet the eye at the first point. I think we've got time for just one more quick question. There's an interesting thing about how you would approach human factor vulnerabilities, fatigue, and information overload, and has that actually been built into any of the systems you're doing?
So it will be part of the observation. So in terms of the systems, we have arrangements in place to manage that type of risk. When we are risk assessing any task, if fatigue or any other human factor is a potential hazard, then it will be part of the risk assessment. I think in terms of the human factors, one of the benefits of Safety 2 and going to look at what looks right is actually being able to observe that as well. Because as a team, you quite quickly get used to each other. As an operator, you get used to your own mindset. Sometimes it takes a third party to actually observe that issue, whether that's fatigue, whether that's lack of concentration. So actually having people out in the park observing could potentially help that.
Okay, great. Thank you very much, Christian. I think we've run out of time for questions, so I'll just hand you back to Elsa to wrap up the event. Thank you.
Thank you.
Elsa?
Thanks, Christian. That's been a superb presentation this afternoon, and I think it's certainly generated a huge amount of discussion and questions, and I think left us all better informed. It certainly left me with a lot of things to think about with the different people we work with about who's sitting where, and we'll never lose the need to go back and look at major incidents, but there is so much we can do to concentrate on the things that we do right. And any of you who brought up children know that the more that you focus on the behaviours that you want to see more of, you get more of those behaviours, and we can apply that in our workforces too. So thank you for a great presentation.